Well, I mean, just looking at this, what they're saying about equal vectors, two vectors are equal if they both have the same what? Magnitude, and the both of them are moving in the same direction. All right. So as you can see, you have CD and you have what? GH, and both of them have the same magnitude. How do you know that they have the same magnitude? Because all of them have the same values, 3, 3, and 3, 3. And how do you know that they're moving in the same direction? The arrows are both pointing in the what? The same direction. So that's why they're called equal vectors. I'm going to try my very best to make this, to have this recording available tonight. Because if I don't do it tonight, it's going to take forever. Yes?
Sir, you were saying that the two vectors are said to be equal if they have the same magnitude and direction. So you were saying because they both have 3, 3.
The same values, right? It's the same numerical values determine the magnitude.
Okay, so that would be the magnitude, right?
Right.
And they're both going in the same direction.
Right. And you look at the arrows.
Yes.
Right. So the arrows tells you that.
Where they're going.
Right.
All right.
Afterwards. All right. So take off this one. So another type of vectors, what we call inverse vectors. All right. So let me just briefly explain what this is all about. When two vectors have the same magnitude, listen carefully. When two vectors have the same magnitude, but what? Opposite direction, then one vector is said to be a what? An inverse of the other. So inverse vector have the same magnitude, but opposite direction. As you can see, A to B is what? 2, 4. But Y to Z, as you can see, is going in opposite direction. Not sure. Look at the arrows. All right, and look at what you notice about the values for Y and Z. They become what? They become negative. They become negative, right? So both of them are positive over here. Both of them become negative over here. All right. Now, not because both of them are negative, it doesn't negate the fact that they have the same magnitude. And I'm going to show you how that is possible. Okay, you might be saying, boys, sir, negative 2, negative 4, those are smaller numbers. You could argue that, not true? But look at it, 2 and 4, and you have negative 2 and negative 4. Alright? And you might, so I'm going to show you how these two values are actually the same. What do you think magnitude really is? Magnitude is really the length of the line, you know. That's what they're talking about. So magnitude, when they say magnitude, they're talking about the length of the line. So the longer the line, the bigger the what? The magnitude. Shorter the line, smaller the magnitude. All right, so what are parallel vectors? So vectors, and you'd have come across this word already, that's true. Parallel. When two lines are parallel, if they travel in the same direction, you'd have probably learned about that. No, vectors are parallel if they have the same direction. All right, but guess what now? How do you prove that two vectors are actually parallel? How do you prove it? Well, it's a little more technical when we're doing vectors. It says that two vectors are parallel if they are a scalar multiple of one another. What does that mean? It means that two vectors are parallel if one vector is a exact multiple of the other. Meaning that, for example, if you're to look at this example here, do you realize, okay, so let me zoom in a little bit. It's it's not so clear. All right, so yeah, that's a bit clearer. All right, so what happens if you look at RS, right? RS is 2,1, but VY is what? 2,4. Would you agree with me that if you multiply RS by 2, you get VY? What's 2 twos?
Yes, sir.
2 twos is what?
Who's 4?
And 2 ones is also what? 2. So what you notice? VY is a multiple of what? RS. All right? Now, tell me if this is a true statement.
Could you say half of it?
Right, very good. You could also say that half of VY will give you what? RS. All right? Yes, that is so true. All right? Sometimes we get something like this. We get this vector equation, 2RS is equal to 1 VY. Or you could say RS is a half VY. All right, so both of these are the same statement. So if you can find a number that when you multiply one of them by another number, then that means what? They are parallel. All right, any questions? Let me give you an example. Suppose you have AB. All right.
Sorry, do you want to write up there, so you know?
No worries, man. There. All right.
You can rub it out now, sir.
All right. Yeah, so let me give an example. Suppose you have this vector here, AB, right? I'm not going to draw anything. I'm just going to put in the values. Suppose you have AB and AB is negative 4 and 6. And we have XY. All right. This is my question to you. Are these two vectors parallel?
No, sir.
All right.
Unless you
Yes.
have 8 at the bottom.
What is the definition of when two vectors are parallel? Two vectors are parallel
Well,
if they
when
go
they're
in
multiple,
same direction, and if you can
Multiple.
and if you can find one number that when you multiply the other number by it, you get the same thing.
Sorry,
Almost.
hear me, sir?
Negative 3
Mhm.
multiplied by negative 4.
Sir?
Yes, hold on. Yes, John, you're saying something?
No,
Say if you can multiply
very
negative 4 by
because
6,
my
you get
internet
negative 12.
Just hold on for a second. John is saying something. Yeah, go ahead from John. There was a little distortion a while ago.
Oh, sorry, I was thinking that you
Mhm.
say it said the vectors are parallel if they are scalar multiples of one another.
Mm-hmm.
So that means if the negative 4 can multiply by another number and you get a negative 12,
Mm-hmm.
and the bottom one multiply by another number, you get the 18. So there will be it would be a parallel vector.
Mm-hmm.
Okay.
All right. Can you find a number?
I'm thinking, sir.
Okay.
I know
Number
since
would be
6 is 18.
Can you multiply AB by a number to get XY, or XY by a number to get AB?
yes, sir. The number would be 3.
The number will be 3. Very good. Very good.
Yeah.
All right.
But Janet, you made an error though. If you're gonna multiply negative 4 by negative 12, you're gonna get a positive answer.
All right. But guess what? You think about if you multiply everything by 3, AB by 3, you actually get what?
Mm-hmm.
XY. Wouldn't you agree? So 3AB gives you what? 1XY. So therefore, AB and XY are parallel. So they are parallel. Yeah. Because 3, 6 is 18. 3 times negative 4 gives you negative 12. Or you could divide XY by what? By 3, and then you get what? AB. So they.
Sir. So sorry, you couldn't divide like 4 divided by 12 and 6 divided by 18, and then you get the answer.
Sir, my kind of lost.
Hold on. Hold on. Say that again.
Like you would say negative 4 divided by negative 12, you would get 3, negative 3. And 6 divide 18 divided by 6, and you would get 3. Negative and negative divided by, you would get 3. Negative 4 divided by negative 12, you would get 3. And 6 divided by 18, you would get 3.
Oh, you're talking about to figure out to get the number 3.
Yes.
Yeah, man, you could do it that way also.
Okay.
But I was just saying, boy, it's just easy timetables, Yeah, but you could do that. But the most important thing that both numbers have to be the same. So in other words, I suppose this 18 was say 20. It wouldn't be parallel because there's no number you can actually find to multiply everything AB by to get the same thing over here. So if 18 was 20, it wouldn't work.
Right.
All right. I'm getting some mess. Hold on it. I think Kristen. Okay. Okay. Nikisha said I was breaking up. Kristen is saying that. Kristen, are you hearing me?
Yes, I'm hearing you now.
All right. You were saying something? You were asking a question?
Yes.
All right. Go ahead. Sorry about the delay. Mm-hmm.
I think it already. Not sure I was going to ask if the two parallel points, right? Like you have RS and VW.
Mm-hmm.
It's supposed to be the one number that we divided or can go with all of them.
Right. One number, only one number. So you can't have two different numbers. So in other words, you know what I'm saying? You can't have two different numbers. It has to be one number that you multiply by RS to get VY or VY to get RS. All right. Are you following? Just like this one here, though. Well, notice 3 was the only number we can multiply AB by to get what? XY.
Sir, I don't want you to go that far, and then when I tell you, say why I never say something. I want to tell you
Yeah,
something.
man,
before you go
I
that
hear you,
far.
man. I'm trying to see if I can address.
This is Karen.
Come
Okay. Okay.
Come on, somebody was there. So, Kristen, are you following?
Okay.
All right, so I'm not getting any.
Yes, sir.
Yeah, so it's just one number here. It's just one number. So, for example, look at this one. Look at this example here. AB and XY, right? 3 is the only number you can use to get XY. There's no other number. But guess what? We found a number, not true? So the mere fact that we can find a number, use a number to get XY, it tells us that the two lines are parallel. Now, as I was saying, what if the 18 wasn't 18? What if the 18 was 20?
Then you use 2.
But if you use 2 sixes, it wouldn't work. Because
Oh.
2 times negative 4 gives you negative 8. Negative 8 is not there. 2 times 6 gives you
Oh.
12, and 12 is not there. So the two lines are what? They are not parallel. Alright?
Yeah.
They don't
Yes,
meet.
sir.
Right. Alright? Okay, this is very important. Alright. Yeah, go ahead for me now, please.
Oh, sir.
Come on.
The thing is, I don't understand. I don't understand what you're doing over that side. I am looking at the RS the thing over here, and I understand the 4 over the 2 are. But I got lost. I just don't understand nothing that you're doing. Where you get those numbers from, or why you even have those numbers, or the RS or those letters that I'm seeing in the red writing that you took off. I really don't understand.
You mean the
nothing
two, the 2 and the 1 and the 4 and 2?
What you had written
No,
before with the red marker
Oh.
thing.
Oh, that was
I don't understand that.
That was an example.
Oh, but I understand this RS because it's 1 going up and 2 up and 2 across. So I understand that. And I understand the VY because it is 2 going up and 4 across.
Okay.
Mm.
Well, I mean, what you're saying is true, but the point we're trying to bring across is to prove that these two lines are parallel.
Parallel.
That's what we're proving.
Oh, okay.
So to prove that two lines are parallel, what does it say? What the definition says? What do you have in your notes? What do you prove it?
Vectors, two vectors are said to be equal if both have the same.
No. That's equal vectors. We're looking at parallel. Look at the other one.
Oh, parallel. Vectors are parallel if they have the same directions. Two vectors are terminal. I call that word in a kind of common word. Parallel. You can pronounce
Just
the
say para. Lel. That's all.
Parallel.
Yeah. Parallel.
If they are
Para as in paramedic. Para as in paramedic. So parallel.
parallel, they are
How will you pronounce the word parallelogram?
no, sir. Mm-mm.
You want something called parallelogram, you know?
I can't pronounce that word. Sorry.
Alright, go ahead for me.
So, they are scalar multiples of one another.
No, scalar
A
multiple.
scalar?
Yes.
Look here, sir. The teacher make me pronounce something wrong, you know, sir.
No, it's not scalar.
All right, thanks.
Scalar
Pronounce
just means that it's a number. Scalar means number. So it's just a number times the other vector. That's all.
So, sir, for
Hold on. I'm trying to get through to her.
okay.
Mhm. So basically, what is it saying? You see, two vectors are parallel if they are a scale. All right, let me put it this way. Let me put it in layman term. If yes, so as I was saying, you see, in layman terms, if you can find a number that when you multiply the other number by, vector by, and get the other one, then they are parallel. So look at, this thing is in the way. So look at RS and VY. Wait, notice, if you multiply RS by 2, don't you get VY? Or if you divide VY by 2, don't you get RS? Yes. So once you can have that kind of relationship, then the two lines are what? Parallel. And furthermore, if both of them are going in the same direction, that also indicates that they are also what? Parallel. All right? So what I was doing over here was I was just giving an example, but you don't necessarily have to use a graph. It's not a graph thing, although you can use a graph to interpret it. So what I did was to give 2 examples. So I'm going to give.
So, sir, they're going to put that as how you have it on the exam. In the exam, they're going to give more than one or just one of that for us to do. Or they're going to write it in words and we have to figure it out.
All right, so sometimes they'll give you a diagram, and what they'll do, they'll ask you to show that these two lines are parallel.
Oh.
Yeah. So they'll give you a diagram. Hold on, this thing is just getting from bad to worse. Right. So they will give you a diagram and they'll say, okay, prove that these two lines are parallel. All right.
Okay.
So let me give an example. So let me just make up another thing. So let's say you have is -5 and -10. And you have an next vector, Mn. And Mn is 1 and -2. This is my question, right? Are these two vectors parallel?
Yes, sir.
All right. Now, if you're gonna say yes or no, you have to tell me the relationship. In other words, what you're gonna do, you're going to say P. You're gonna write down PQ equal MN. Then no, what you're gonna have to do now is to find a number right here, so, or over here, so.
Would it be the 5?
All right. Where would you put the 5? Here or here? Left
PQ,
or right?
sir. At PQ?
Left.
So I'm not sure which part PQ there, sir.
Put it where MN is
Yes, it will have to go where Mn is.
as a positive.
Because guess what? 5 times 1, I will give you back what?
1.
No, man. 5 times 1 will give you 5. And 5 times -2 will give you what?
-10.
Right, it gives you back PQ.
Yes.
So I'm saying?
So that means the parallel.
Right. But guess what? If you put the 5 over here, say no. Look, let me show you something. Where is this thing? If you put the 5 over here, so class,
Yes, application.
What you're telling us is that if you multiply 5 times PQ, what is PQ? Let us put a 5 right beside PQ. 5 will give us what? 25.
Yes, sir.
And 5 times negative 10 will give you negative 50. But do we have 25 and negative 50 down here, so? No.
No, sir.
Right, exactly.
Understood. So you'd have to put the 5 beside the MN, because MN
Right.
is 1 and,
Right,
and negative
right,
2. So 5
But
times
let-
1 is 5.
But let me ask a question. What can I put at PQ though? Something can go at PQ, you know?
2 or 1.
5.
No man. It couldn't be
Sir,
it couldn't
Is
be
it
2.
1 or it would be 1?
No,
Or-
it couldn't be 1 because no, what you're saying that these two are naturally equal.
So 2, sir? Or,
Put 2 here, so. But if you put 2 here, so you're gonna say 2 5s gives you 10,
Sir.
but there's no
Sir.
10 here.
Nothing there, yeah, man.
Something can't go there, man. Something can't go there.
1.
No, you couldn't put 1 because if you put 1 there, you're saying that both of these are equal. You're saying that these two are equal. Let me get a hint. It's a fraction.
Half, sir.
But
No.
but half of 5 is
No.
5 over 2.
2.5.
Yeah, and half of 10 is 5.
So think what?
What about 1/5?
Yeah. Yes.
You follow? All right.
So that's what that I was going to ask you, sir, about the first one you do with the AB and negative 4 and 6. It could be, you could have put 1/3, right?
Right. You could have put that 1/3 there. Yeah. Yeah. All right. All right. Okay. Anybody writing this off?
Sir, you see what you have in
Yes, sir.
the triangle? Or rectangle that. The box. What you have in the box?
You mean the
So-
RS and the VY?
Yes, it would be parallel.
Yeah, man, it will be parallel. Yeah.
Okay.
Because 2RS, if you look at it, 2RS gives you what? 1 VY.
Yes, sir.
Or what? Half VY. Half of VY give you 1 RS.
Okay, sir.
All right?
Yes.
Okay. All right. Anybody writing?
So when they ask you that question and you determine and you see that it is the P
You're
word,
going to have to come up with this relationship. Yes. They want
but I
you
would
to
have to
come up with this
work out this
formula.
at showing.
Yeah. You have to
So-
put these two together and find a number. You know what I'm saying?
Oh,
Yeah.
so the PQ signify
The
what?
vector it's just a vector going from P to Q,
Okay.
and another vector going from N to N.
Could you use any numbers?
You mean, yes,
Okay.
they could use any numbers.
Sir,
But-
it's one out of any of the number you must use, whether 1/5 or the 5 with the MN. How it go?
Go again for me, Janet.
Because I see you have 1/5 beside the PQ.
Uh-huh.
So it's just 1/5 would be there for the answer, like that.
No man, all of this will be the answer, you know?
Yeah.
All of this at a circle.
And if you did not use the 1/5, what
you
happened?
would have used
The
PQ,
fact
you'd have used PQ
equal.
equal 5 MN. I was going to write it a while ago.
Right. That's
So
what
you have two answers.
Okay.
Two answers will work. Alright?
Sir, if you pick one answer.
One or the other.
One or the other.
Right.
Okay.
That's what I mean.
Yeah. Okay, let me. Oh, this space looks really messy. All right, can I move on?
Yes, sir.
Anybody writing? All right. Okay. Class activity. 3 minutes. It says state the relationship between each of the following vectors. So we just looked at equal vector, we looked at inverse vector, and we looked at parallel vectors. All right, 3 types. And right here, so they give you what? They give you a pair of 3 vectors. So they want to know what is the relationship between A and B. Are they parallel? Are they inverse? Or are they equal? All right. I can tell that 2 is very easy. Don't you? Look at 2. That's like crazily easy. All right. So 3 minutes. All right. You ready? All right. What's 2? 2 is very easy. It's straightforward.
Equal.
Equal. Not true. Yeah, man.
Yeah.
Equal, sir.
Yeah, man. He's not mad man couldn't answer that question.
I know the bottom one.
All right.
The
What's
P word.
Yeah. What's the other one? What's number 3?
Parallel.
The P word, sir. A
Parallel.
word there.
It's parallel, don't you?
Yeah.
Sir.
Yeah. Because why? Why are they parallel?
You can find a scalar
Give me the relationship. We have M
multiple.
underscore. Remember I told, if you look back in the notes, this is another way of how they represent vectors, right?
Yes, sir.
Yeah. So what number goes beside M or N?
2.
Beside M, I think it would be
Two.
yeah.
Two. It will be 2.
Equals to N.
Yeah, so that's the answer. Or what? What would go beside N?
N.
Sir.
Half. Yeah.
Hey,
Half of
you're
6.
bright, man.
Half of 6 gives 3. Half of 20 gives you 10.
20, 10.
You're absolutely correct. All right. Okay. Virgo is saying inverse equal parallel. Yes, you're absolutely correct. And the top one is inverse, not true?
Yes, sir.
Yes, sir. That was pretty easy, sir. All of them, do you give it to you?
All right. Because these are what we call core concepts. All right. All right.
These are multiple choice questions, sir.
No man, these are core. These are conceptual. These are core concepts. All right. You get application questions in exam. So when you understand the core concepts, then we move on to the more challenging questions. But you can't do challenging questions if you don't understand these concepts, don't you?
So that then if you give in an exam, there is a refilling with. There is a for write that. So it's easy. Sure if you pass it, then set it like that.
Okay.
So you can give us more examples, sir.
You want more examples of these?
Oh, sure. Move on.
All right. I think we can move on because I don't think unless you don't understand. All right. It's pretty straightforward. All right. Let us look at another thing. It's called a gradient. So take off this. It's called a gradient of a vector. This is talking about a gradient of a vector. So the gradient of a vector is really y divided by x. Very simple. Simple formula. So it's just the y value divided by the x value. So let's give an example. Given that m to n is 2, 4, find the gradient of m to n. And gradient, if you were, well, most of you are in the subject class. What does gradient mean, class? Anybody remembers? Gradient is what? It is a measure of what? How steep a line is. And I said that gradient can be positive or gradient can be what? Negative. If the gradient is positive, the line will fall to the right. Otherwise, it will fall to the left. And in relations, functions, and graphs, we use a special letter to represent gradient. Can anyone tell me what that letter is? We did that last week, Saturday. Alright, so it's a letter M, common M. So common M is what we use to determine, well, what we use to represent gradient of a line. But no, we're not talking about gradient of a line. Yes?
The capital M is for the midpoint.
Right, capital M is for the midpoint. Right. Right. You guys have a lot of things to study. Alright, so it's very simple. To find a gradient, all we need to do is just divide y by x. Alright, so it's just 4 divided by 2, which is equal to 2. Alright? Any questions?
So don't move it as it here.
Alright.
They're telling you so that you just flip it. You would flip it.
Kinda, yeah. Flip and you divide. You actually divide to get a number. You actually divide those numbers.
Because it's a given that mn equal to 2, 4. The gradient of mm would be 4 over 2 equals to 2. So you would flip it then.
Right. I wouldn't use that word still, but yeah. Because when you flip something, it's 4, 2. You would say 4, 2. But then when you bring in 4 divided by 2, which is something different. Or you could say flip and divide, actually.
Yes, flip and divide.
All right, can I move on? All right. All right, 2 little questions here for you. So, determine the gradient of the following. Gonna give you 2 minutes, pretty simple to do it, 2 to 3 minutes. All right, sorry about that. Quickly, what's the answer for number 1?
1.5 or 1.5.
Well, it would have been. Wouldn't it be 4 over 6?
That's full of true.
Which is 2 over what? 2 over 3.
3.
Actually.
All right, and what's 2 over 3? What is 2 over 3 as a decimal? 0 point something something, true?
Sir, I thought it was 4 at the top and 6 at the bottom. No?
It is, no, it's the other way around. What is 2 divided by 3 as a decimal?
0.6.
0.6 is a recurrent decimal, not true?
Yeah.
Right, so it's 0.666. So if it will be 0.67 if I say to 2 decimal place.
So you have to put it to a decimal. You have to put it to a decimal after. I can say at 2 over 3.
Yeah, it is advisable that, no, it wouldn't be 4. It is advisable to you could leave it like this, or you could leave it like this.
Oh.
All right.
Put that as decimal.
You use the calculator or you do long division?
Janet, you just said 2 divided by 3. And I get 0.666. 0.6666.
This one is 12 divided by what? Negative 3, which is
negative 4.
Negative 4. Awesome. Very good. Any questions? No, do you realize that the second gradient is negative? It means that the vector will be like this. It will shape like this. Like J.
It'll be an inverse.
Well, when we talk about inverse vectors, we have to be comparing with another vector. So we're not comparing this vector here with any other vector.
Oh, that's a minute.
Right. So basically what I'm trying to say is that the gradient is negative, so the vector will be falling to the left. So it's like you have a bamboo stick and it's falling. It's like it's going to drop to the left. But this gradient is positive, not true? Top one. So it probably look like this. Falling to the what? The right. So L and M. All right. All right. Any questions? All right. Moving on. So we just looked at the gradient of a vector. Now we're going to look at what we call the magnitude of a vector. All right. Let me see if I can capture all of this. I doubt it. So let me just how do you shrink this again? Oh. All right. So I guess. Yeah. Okay, so take this off. 3 minutes stops. The magnitude of a vector. And an example comes with it. All right, so you've been hearing me talking about the magnitude of a vector quantity, not true? So, and I would have given away and told you that magnitude, they're actually talking about the length of a vector. All right. So it says the magnitude of a vector AC is the distance between the initial point A and the end point C. In symbol, the magnitude of AC is written as AC arrow with these two columns. All right. So this is another way of asking. So you might go to an exam and see something like this. What are they asking us for you to find? They're asking you to find the magnitude. Can somebody relate this symbol to another symbol used in another unit topic?
So we are calling again.
Determinant.
Right, very good. Determinant of a matrix is the same symbol, not true? Right, very good. And like we're on determinant, how do you work out determinant of a matrix? What do you do? I mean, I know we're not doing matrices, but you know. Anybody remembers the formula?
Sir, AD minus BC.
Right. In other words, it's the product of the leading what? Diagonal. Subtract the product of the non-leading diagonal. All right? Right. So you should be constantly practicing. Remember, you know, guys, I mean, you're not going to do this forever, you know. You just only want to do this for a moment. So set up a timetable, roll up your sleeves and just try to say, boy, you know, and get over with it. And set up a plan of action of how you're going to tackle this. You know? All right. Okay, let's get to the question now. So it says the symbol for magnitude is that, right? And they give you the formula. So this is the actual formula. Let me highlight it. This is the real deal. That's the formula. What the formula say? You're just gonna square the x value, square the y value, add them, and then find the square root of it. All right? All right, so let us look at an example. It says, given the vector mn is 3, 1, determine the magnitude of mn. So it's very simple. You just square root, then you square 3 plus the square of 1. Now 3 square is 9, 1 square, well, 1 squared is 1 times 1, which is 1. 9 plus 1 is what? 10. And the square root of 10 is 3.16 units to 2 decimal place. Are we clear? Any questions? And I know you know how to use your calculator to get that, right? All right. Any concerns?
Sorry, I forgot to remember all these formula.
All right. Let's move on since there's no question. All right. Okay, so we have a little activity here for you. It says determine the magnitude of JK and double X. All right, so I'm going to give you 5 minutes to work this out. And try to answer part 2 also. So you're going to find the length of JK and double X and observe what you notice about them in part 2.
Yes, sir.
You want to walk us through? All right,
Yes,
let me get the. All right, so we're going to use up the notation. So according to the formula, what am I going to write?
-3.
Oh,
sorry.
You're all right.
Sir, now go. Would you do it, sir?
All right.
So, sir, it will be -3 square plus 4 square.
Mm-hmm.
Then you draw back the. Yeah. So you're gonna have 9 because negative times negative positive plus 16. You're gonna draw back that again, sir. You're gonna have 25. And the square root of 25 is 5.
All right, so it's 5 units.
Yeah, 5 units.
Very good. Any questions? That's the magnitude of JK. All right, what about the magnitude of double X? Who want to take on that one?
Me, sir.
All right.
So it would be the square root of -6 square plus 8 square. So that would be 36 plus 64 equals to 100. Square root of 100 is 10 units.
Very good. What do you know about these two vectors?
So that they're
multiples.
equal. They're equal to. Are they a multiple of each or some?
Would it be the parallel ones, sir?
They are parallel, right? That's the word I'm looking for. They're parallel. Because as you can see, if you multiply jk by 2, wouldn't you get double x? What's 2 times negative 3? Negative 6. What's 2 times 4? 8. All right. So to answer that question, what do you know about the vectors jk and double x? They are parallel. All right. And there's no space here, but let me again scribble. So for 2, they are parallel. And I'm going to write on the relationship. So you could say 2 jk gives you 1 double x. Or what's other relationship you could get?
You have to write with some more up.
Oh, you're not seeing it?
No, sir, just see like.
All right. Tell you what. Can I erase anybody writing off the working off for the magnitude of jk and double x?
No, sir.
All right. Can I take it off? All right, I'm gonna take it off. Right. So it says, what do you notice about jk and double x? Well, just by looking at it, we see that if you multiply jk by 2, we get double x. Right. So that's the answer. They are what? They're parallel, aren't they? Because one's a scalar multiple of the other vector. So you could say since two jk is equal to 1 double x, then jk, the vector jk, and the vector double x
Are parallel.
are parallel. All right, so I trust that you guys finished by now. So let me go down here. Can I move away from this screen? Everybody finished taking off the notes?
I'm finished, sir.
All right. Anybody else writing? All right. All right, let me just go down here and let me just explain something to you. It's pretty simple. All right, now let us say we have point A. Oops. We have point A, and we have another point called point C. All right. Now let us say we have another point called B. It's a very simple concept. All right. Now I ask you, give me 2 ways of getting from A to C. You say, sir, let's go straight to it, right? All right. Sir, give me another route. Well, you could go from A to where? B, and then B to what? C.
That's the only way you can go, sir.
Hold on. All right. Say that again.
I'm asking if that's the only way you can go. C to A to B, and then B to C. Will you go like from A to B and B to C?
Come on. No, listen carefully here. Listen carefully. Remember, no, vectors has to deal with what? Starting point and a what? And an end point. Right. So, yes, you could actually do that, but I mean, I wouldn't want to go that route now. So I'm saying?
Okay.
If I'm introducing a concept right now, I wouldn't want to go that route right now. But yes, you can. So let's say this is our starting point, A, and you have another destination called what? C. All right. So let me start again. You have a point called A. You have another point called C. Another point called B. Let us say, for argument's sake, you want to go, listen carefully, you want to go from A to where? To C. You'll go that way, don't you? What's another route? A to B and B to C. In other words, AC. To get AC is just the sum of AB plus BC. Would you agree? Or you could rephrase it another way. You could say what? AB, vector AB
plus BC.
Right, plus BC
equals to AC.
What's AC? Everybody get that? So basically, what am I trying to say? That if you add this portion of the vector and this portion of the vector, it's going to be the same thing as what? That distance. That's basically what you're saying. Have you ever heard the term the shortest distance between 2 points is a straight line? Have you heard that phrase before?
Yes, sir.
Yeah, man. For example, let us say you're on the play field, right? And there's a goalpost, one end of the goalpost to the other end of the goalpost. There are different ways you could go to the goalpost, aren't there? What's the quickest way? A straight line. Yes. So the shortest distance between 2 points is a what? A straight line. It's the same concept they're trying to build right here. All right. Now let us create two new formulas now. Suppose I want to make AB the subject. What I'll do, I would say AB. I would subtract BC from the left and BC from the right. So I'll get AB equals AC, subtract what? BC. What is that? Or in other words, I just bring over what? I don't normally teach it this way, but you bring over BC becomes negative BC. So what I did was to create, but if I remove this, if I close it, I'll go in. I don't want to do that. All right. Likewise, suppose you want the vector BC. Can somebody tell me what the formula is for vector BC?
AB minus AC.
It will be no man. Walk AC will come first. AC will come first.
Minus AB.
AB. All right, and I believe those are the two formulas at the bottom. Not true? Right.
Yes.
So you don't have to write this here because you would have written all of this would have been in your diagram above you. All right, it's the same thing. So let me just go upstairs now. All right, so this little concept will take us out for today's session. So what we'll do next week, Wednesday, is more vectors. All right, I am hoping and praying that I don't know, there can be some extension of the time. Not true, because I'm thinking if exams are going to start the 30th of June, which is the last working day in June, math would be probably around about the 14th or the 15th, or either the 14th or the 15th of July. You know, so we have a good 4, 5, 6, probably seven more classes. You know. But I don't know how viable that is in terms of additional hours, because the term would have been finished, Andrew.
Sir, the additional hours is gonna be a problem for me now, sir, because I go work from 5 o'clock in the morning. So it's really hard to be staying up so late and then I have to be getting up so early.
All right.
Sorry, you have a lot leave to finish up the syllabus, sir.
All right. Hold on. Let me finish off this first before we continue here.
All right.
Because I'm going to have to edit out all this on the side in the recording. All right, let me just finish this. As you can see, AB plus BC. Look. Hold on. Where is this thing? Where is this thing? Okay. Spotlight. Okay, all right, cool. All right, so as you can see, we have A, we have C, and we have B. And let's say we want to go from A to C, right? We can go straight to C, just by that. Or we can go from A to B plus B to C. As you can see, AB plus BC gives you what? AC. All right. What they have done, you see, is actually tell you, give you an example. Because if you look, AB, if you draw a triangle here as a class, look, that's how many units to the right? 4, not true? Is that so? And how many units going up? 5. So vector AB is actually what? 4, 5. Everybody see that? Look, come again. A to B. Go across. How many units going across? 4 units. So you put the 4 at the top and 5 units going up. So we'll put the 5 at the bottom. So this vector here represents what? Vector A to B plus B to C. So we're over here now. B to C. All right, tell you what, let me change this to a marker. So vector B to C, if you draw a triangle like this, all right. So it's how many units going down?
Okay.
It's 2.
1, 2.
Right.
Negative
And
2.
then no what? 5 units what? Across.
Going up.
So vector BC is what? 5 negative
across.
2. All right. So if you're to add 4 plus 5, you get 9. Add 5 plus negative 2, you get 3. So essentially,
3.
Essentially, if you were to algebraically or numerically add these two vectors, you get 9, 3. And if you're to literally check AC because what they're telling you, they're telling AC, the vector AC, according to the triangular law,
would be 9, 3.
9, 3.
So let me check it.
Let's check it now. This is a triangle, true?
Right.
We're gonna go how many units to the 9? If you count those, you'll get 9.
To the right.
And then we're gonna go 3 units where? Up. Right.
Okay, I see.
Right. And then what is down here is when you transpose AB. For example, if you want AB, just bring over BC, so you get AC subtract 1.